Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called two eggs. It's an easy problem, however, in my opinion, is not that easy. Right? So we've been given a 100-story building where there's floors from 0 to 100. There is a particular threshold floor that we don't know of yet. So let's just call it x. And x could have a value anywhere between this range, such that from any floor above the floor X, if we drop an egg, then it's going to break. So over here, we've been given that an egg breaks only if dropped from above a threshold floor, say the value is X, right? And we've been given two eggs in total. That means that we can only break two eggs. Once we break both of the eggs that we've been given, we don't have any more eggs to test out which floor is actually the threshold floor. Now we have to devise an algorithm, right, to reduce the threshold floor x in the minimum number of attempts in the worst case. Now what does an attempt mean? An attempt means, say I take one of my eggs, I go up to floor number 33 and I try to throw it downwards, or I just try to drop it from that floor. Now it could either break or it might not break. Either way, this is counted as one attempt. So our final goal is basically to this. This is what we have to focus on. So just to simplify everything for you guys, we'll play around with a few examples. So the first example we're going to take is imagining we had only one egg available with us, right? And we were to find the threshold value x. Now, just for random sake, imagine I went up to a random floor, say 50, and I dropped the egg. Now, if the egg doesn't break, then great. I know that there's going to be no floor beneath floor 50 from which it's going to break, because it didn't even break on 50. So my x value is either 50 or greater than 50. That's the information I got. But the problem arises when it does break, when we dropped it from floor 50. What happens now is I have no idea whether x was 49 or anything below 49. It could have been all the way down to x equal to 0, right? And since I've used up my single egg, there will be no way of confirming that what's the value of x. And since we have to find out the value of x, no matter what happens, so this is where considering the worst case becomes important, right? What that means is no matter what happens, our strategy must work. So obviously this isn't a way to solve it. So what happens is when we have one egg, the only true way to solve it, considering the fact that it must work in every single case, is to drop it from every single floor starting from the floor number 1. Why is that? Because if it breaks from floor number 1, we know that the threshold value is x equals to 1. Because, so it can't be x equal to 0, by the way, right? Since we can't really drop it from a floor which is basically on the ground already. So so 1 could be the lowest value for the threshold. Now, so we have to try, so we try out x equals to 1 first. If it breaks, then we know that, well, x equals to 0 was the threshold. If it doesn't break, then we know that x equals to 1 could be the threshold value. Then we go on to floor number 2. We drop it from that floor. If it does break, then we end our algorithm. We know that x equals to 1 was the threshold. If it doesn't break, then we know that x is at least equal to 2 or greater. And we keep on continuing this process until we find a floor where it breaks, or we reach floor 99 and it doesn't break. In that case, we just know that, okay, the threshold value, sorry, floor, until we reach floor 100 and we drop it from this floor, right? And if it doesn't break, then we just know that, okay, since there can't be any numbers above that, so x is equal to 100. So we have to start from the value number 1. We go all the way up to 100. So this takes us 100 tries in the worst case, 100 attempts rather. So this is an algorithm, and this is actually the only true algorithm that would work given we had only one egg. So now you guys can try to think about different type of strategies that we can apply when we have two eggs, right? And one of the first strategies that comes up is to drop it at a particular gap, a continuous gap. So let's say we'll keep our gap as 25 for now, right? So I go up to floor number 25 and drop my first egg. Now, what happens is, if my egg breaks, then I'll have to start from floor number 1 and go all the way up to floor 24. And why am I doing this? This is because since it broke on floor 25, the value of x is either 24 or less than that, right? So I'll start by 1. Since I can't even start by 2, because if I start by 2 and it breaks on floor number 2 again, then there's no way of finding out whether it was actually x equal to 1 or 0. So that's why I have to start from the floor 1 and work my way up as if this is actually completely identical to the case where I had one egg, because one of my eggs has been used up on floor 25, and now I'm sure that it's either it's between this range, but I only have one egg, so it's gonna take me 24 tries. So in this particular scenario, it took me a total of 25 tries. Let's say it didn't break on 25. Okay, so if this doesn't happen, then I jump all the way up to 50 and try to break my egg. If it does break on the floor 50, well, I know it didn't break on 25, so x could be 25 or greater. I know that it did break on 50, so x is less than 50. And now I am left with one egg only. So what I'm going to do is going to try each floor from 26 all the way up to 49. So again, these are 24 tries. This is one try, and the 25th was the first try, 50 was second try, and then there's 24 more tries. So this adds up to being 26 tries in total, which is one more than 25 over here. So let's update the worst case scenario number of times to 26. Now I'll go up to 75 and do the same thing. So this time around, let's say it does break, and I'll have to check all the 24 values in between. So since 25 was 150 was second, 75 was my third attempt, and it breaks over there, and then I have to do 24 more. Now this time I took a total of 27 attempts. So this is our new max value. And let's say it didn't break on 75. Well, it's always going to break on one. We already know that 100 is the maximum value. So we could just start. So we'll go all the way up to 100. That would be our fourth attempt. And then we'll go from 76 all the way up to 99. So that's 4 plus 26. So that's 30. So we managed to reduce the number of attempts from 100 attempts in the case where there's only one egg to, in the case of two eggs, since I chose the gap as 25, we got a value of 30, sorry. But we obviously could do better. And once you start playing around with the number of gaps, or the size of the gap rather, and trying to see how many attempts it would take in the worst case, we would reach the best possible option of when the gap is equal to 10. In this case, it takes us just 19 attempts in the worst case to find out the value of x. However, this is not the optimal solution. And the trick lies in the fact that the gap size does not have to be continuous. Now, what does this mean? This means that for my first attempt, I could have started at, let's say, 20. And then for my second drop, let's say it didn't break on 20, it could have gone all the way up to 38. So this is a gap of 18. And then I could have went, well, just for random values all the way up to 50. And this has a gap of 12. So it's not necessary that my gap has to be a constant value. By having a variable gap size, we can decrease the amount of attempts further. So try to think of a solution with a variable gap size. So the most optimal way includes the trick that we have tried to make sure that it takes us the same number of attempts no matter how worse the case becomes. So how do we do this? In order to achieve this, what we have to do is whenever we try to drop an egg and it does not break, we decrease the gap by 1 for the next floor that we try to drop the egg from. Now, what does this mean? So imagine we have this building over here, a 100-story building. Imagine I first drop the egg from a floor N, right? Now, if it does break, then we have to check all these n minus 1 values. So in this case, the number of attempts that it will take me would be n, right? Let's say it does not break from this floor. Now, since I just mentioned that we decrease the gap by 1 every time, I go to floor number n plus n minus 1. So that the gap from between is n minus 1. Now, if it does not break from this floor, then we just go to n minus 2 more floors upwards. If it does break, then I have to try these n minus 1 values. Sorry, n minus 2 floors in between. Since there's n minus 1 floors in between over here, there's going to be n minus 2 floors in between over here. So what happens in the second case where it broke on this floor was that I did one attempt, second attempt, and then n minus 2 more attempts. So this also adds up to n. Now let's say it didn't break on this floor either. So I had to do my third attempt on n plus n minus 1 plus n minus 2, this floor. And there's n minus 3 floors in between. So so since n was 1, this floor was second, this was third, and there was 3 in between, n minus 3 in between, sorry. So this also adds up to n. So by doing this, you can realize that essentially no matter which floor on which floor the first egg actually breaks on, and by this method, we can see that no matter which floor it actually breaks on, and by that I mean no matter what kind of scenario comes up, it's always going to take us n number of attempts to find out the value of x. And as you can see by the pattern over here, the constraint on this type of algorithm is that the value of n plus n minus 1 plus n minus 2 all the way up to when we could only add one more gap has to be greater than or equal to 100. Why is this? Well, let's say my n value is 5, right? Then the next time I go to 9, then 12, then 14, and then 15. Now after 15, my gap value is already at 1. So to go all the way up to 100, it's going to take me, like, I didn't reach 100 over here in this way, right? So this algorithm won't work. I have to find a value of n such that by the time the gap becomes 1, we at least have reached 100. So, and since we want the minimum value of the number of attempts required by our algorithm, we want the minimum value of n that satisfies this equation. Now, since we know that the sum of this expression basically becomes n into n plus 1 by 2. And putting that greater than or equal to 100, our n value comes up to be 14 as the minimum value of n that satisfies this equation. So n equals to 14. Now, how does this algorithm really look like since this is the actual solution? I go to floor number 14 first. If it breaks on floor 14, I try 1 to 13. So in this way, this counts as the first attempt, and this counts as the next 13 attempts. In the worst case, it took me 14 attempts to find the solution. If it does not break on 14, I add 13 to this, and I go to floor 27. And if it breaks on 27, then in between the values 15 to 26, these are 12 values, and one for 14 and second for 27. That's 2 plus 12, again 14. If it doesn't break on 27, I add 12 to it, I go to 39. Then I add 11 to it, I go to 50. After 50, we go to 60, then 69, then 70. Now I'm adding 8, so 77. Now I'm adding 7, so 84. Now I'm adding 6, so 90. Now I'm adding 5, so 95. Now I'm adding 4, so 99. And then 103. But basically, I can stop at 99. So once I reach 99, I could just say that, okay, well, I can just try 100. If, let's say, it didn't even break on 99, then we can just try 100. And this would be less than 14, since 14 is 1, 27 is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It only took me 12 cases, attempts. And you might think, okay, what happens if it, let's say, it broke at 90? Well, so 90 was 1, 2, 3, 4, 5, 6, 7, 8, 9. So 90, up to 90, you took 9 attempts. And then since it broke at 90, and we know that it didn't break on 84, all we have to try is 85 to 89, which are 5 values. So 9 plus 5 again comes out to be 14. So in this, using this algorithm, 14 is the worst case maximum number of attempts that it would take. Actually, it would take 14 attempts in almost every single case, since we've spread out the gaps in such a particular way. I'm also providing the written Brainstellar solution over here, since this is a long solution, and I recommend you guys to go over this written solution too. Thanks for watching.